Did that work? Is that working?
Well, there is always a delay. Um,
There's also a I don't think it's actually starting yet until
there we go. I see it.
oh do you? I don't
Ooh,
see it yet.
I got it.
Oh.
Uh,
Well, you're lucky. I didn't get anything.
I have it here ready to go. All
Okay, well,
right.
hey, if it's working for you, then I guess that's all that really matters, huh?
That's all good. Yeah, I got it. All right. So, welcome everyone to our virtual Starry Nights. My name is Kyle. Joining me is
Hi everyone. I am Malcolm.
excellent. Welcome. And joining us in the chat here, moderators Matthew and Rohit. They'll be looking at any kind of questions or concerns or comments that we might see out there in virtual space. But welcome. We had a bit of a dry spell for the last few weeks, and really excited to finally see some beautiful objects this evening. And just kind of one thing as well, because we're kind of going into the summer months, the it doesn't really get dark until much later in the night. So kind of when we start off here, we'll be focusing on some more brighter objects. As you can see, we're starting with the king of the planets here. And we'll move into some beautiful star clusters. And once the night kind of progresses, we'll eventually get to some deep sky objects, which are quite dim. So we have to wait till it's darker. But that's kind of the itinerary. Um, I don't know. Any other comments on that, Malcolm? Or think we're ready to
Yeah,
go here?
I guess the only real comments is that winter is better. It's the superior season. Yeah.
That is true. That is true.
Oh my
Uh,
gosh, someone agreed with me.
yeah, I mean, aside from the clouds and the rain, though, right? I mean, then we can't see anything.
Yes,
But
yes. Aside from, well, I don't know. I like the rain. I'm a big rain person, and like it makes me feel comfortable. But I'm a
hey,
deep
hey,
case.
listening to the rain with like a good book out with a nice warm cup of tea. That's a good night for me right there.
Yes, I can 100% wholeheartedly endorse that. Yes, I agree with that.
Oh, but yes, just like what Malcolm said, yeah, winter is good because it's longer and darker nights, so you can see a lot more cool stuff. Uh, but yeah,
Yes.
okay, all right, let's get into it. So we are starting with the glorious planet Jupiter, and from here, some things are kind of interesting to see right off the bat here. You can see there's two kind of dark bands that are going across its surface there. Those are the north and south equatorial bands. And the reason why they're kind of a different color is because they're kind of a different mixture of chemicals in the atmosphere, right? Especially with all the storms and Jupiter's turbulent atmosphere, lots of churning and chemical mixtures are happening all at once. So you see kind of that discoloration there. But what's really interesting as well is how far away Jupiter is. Like it's nearly 1 billion kilometers away, right? And it takes light probably about 45 minutes or so to get there. So you're seeing Jupiter as it was 45 minutes ago. So that's really quite something, I think. And I think some really topics right now is the new Clipper mission is on its way to Europa to kind of survey the surface of that moon because it's quite exciting. It's a an ice moon with potentially global ocean underneath, which is quite fascinating, and why we want to get there so quick. So yeah, really cool stuff. And even now, if you there's a probe called the Juno space probe that's currently orbiting Jupiter, and it's in this highly elliptical orbit, so it takes it really close to the upper parts of the atmosphere. It doesn't touch it, of course, but really close, and then kind of follows that ellipse. That's why it's called an elliptical orbit, all the way out thousands and thousands, even hundreds of thousands of kilometers away from the planet. And the reason why Jupiter or Juno is there is to also survey the atmosphere and seeing what kind of cool science is happening. Now, if we're lucky here, sometimes if you look hard enough, you might be able to see the Great Red Spot. But I don't know. Do you see anything, Malcolm?
I I can't see anything. No, it is
No.
quite a yes. No, it is not really something that is possible to see, unfortunately, as of right now.
Unfortunately, yeah, that's fair. However, sometimes you don't even have to wait long. I mean, because one day on Jupiter is like 9 hours, right? Like it's so quick on how fast it rotates, right?
But you
And
you definitely wouldn't want to be on there for a day. You probably wouldn't even want to be on there for a second, to be honest with you.
no, I mean, like tens of thousands of kilometer winds are whipping around you, and there's lightning storms all over the place, and it's also incredibly hot the deeper you go into Jupiter,
And
right?
pressure. Yeah, there's a lot of pressure in there as well.
And pressure. So, in addition to like an atmosphere that hundreds of kilometers thick, of course, with the deeper you go in places, the more pressure there is, right? It's almost like the ocean. The deeper you go into the ocean, the more pressure is exerted on you. And what's really fascinating is if you go deeper into Jupiter, all of that pressure starts to compress the gases until it forms a liquid. Literally, the weight of the atmosphere forces the molecules together into a liquid, right? Which is incredible. And then you go even further, deeper. And so, okay, say you survive. You won't, but say you survive. Uh, and you go deeper into this ocean. And it's like, firstly, it's an ocean of like liquid natural gas and everything, right? Um, but the deeper you go still, that pressure continues to mount. And eventually all of that liquid gets compressed into a solid, which is incredible.
Actually, on that topic of falling
Yes.
into a lovely gas giant like Jupiter, you don't do it. Don't do it.
No.
No, don't do it. But if you did, you would never actually reach. If you could survive, you would never actually
Mhm.
reach the center of the planet because as you fall into the planet, we expect that you would at some point start being suspended inside the planet. The
Right.
buoyancy of the gas would actually cause you to be stuck in place, floating in the planet. So you would never reach the center of the planet. I mean, you'd probably be crushed, but that semantics. We don't need to worry about that.
Semantics. Astronomy semantics.
Astronomy semantics. Yeah, it's like falling into a black hole, you know? It's the if you could survive, you
Yes,
can't, but
absolutely.
if you could.
hmm What would happen? Anyway,
Yeah.
yeah. So Jupiter, really cool planet, and even so, its four Galilean moons are also quite a spectacle to see. And this was like one of the major discoveries that Galileo made, which is why they're called Galilean moons. Where he realized when observing Jupiter, again, this was in like late 1500s, where he was observing Jupiter over subsequent nights and noticed that these quote unquote stars seem to move really quickly and they seem to go back and forth next to Jupiter. Now, if you just looked at a circle that's held at horizontally, right at your eye level, and you put a ball on it and you spin it, it looks like that ball is just going back and forth, right? And so you realize that, oh, maybe these stars aren't stars at all and are actually something else, moons, that are orbiting the planet. And that really, in addition to a couple other observations, solidified his findings that the Earth is not the center of the solar system. In fact, the sun is.
It
Profound
is,
at the
yeah.
time.
Yeah, actually, one of the other cool things, unfortunately, it has gone down now, but on the topic of
Hmm.
planets that helped us realize we are not the center of the solar system or the universe, the one of the others that was pivotal in that was Venus, because we saw that when we looked up at Venus, it had phases like our own moon. And the reason it had phases is because it sits between us and the sun. So as it's orbiting around the sun, in theory, the only times we'd be able to see a quote unquote full Venus is when it's on the complete other side of the sun from us. Now, please do me
Right.
a favor, do not look at the sun. It won't work.
No.
Yeah, that
Um, yeah, that's fair. That's fair. But if you guys ever have a chance to see Venus during the day, because that is possible, although do it safely, just like yeah, just like we said, do it safely. You can actually see the phase that it's in, right? Um,
yeah.
which is really, really cool.
Actually,
Yeah.
in the night sky right now, like as of recent, the last couple of days, you may have seen as the sun was going down, above where the sun was, there were two really bright looking stars. Those are not
Mhm.
stars, those are planets. Now, I believe the super bright one is in fact Venus, and the one following it is Jupiter. Although you will have to, Kyle, you may be able to fact check me on that. I believe that's the case.
Yes, the brighter one is Venus, and it's
Okay.
closer to
Yes.
the horizon. Yeah,
Yeah. Okay. Thought so.
absolutely.
So yeah, you can
Yeah.
already see Venus and Jupiter. You probably could right now go outside and see Jupiter just sitting above the horizon or a bit above the horizon right now in
Mhm.
the west. Yeah, west.
In the
It's
west.
it's quite bright. Um, it's much brighter than any of the stars, I believe, in the night sky right now. So if you went out and you could probably see it, that is indeed the large planet we are looking at
Mhm.
over like
Oh,
almost a billion kilometers away.
yes. Such a lovely planet. But we've been pretty terrestrial up to this point. Shall we venture out into deeper waters here? Or
Oh, I
deeper
think we
cosmos?
should. I think we should. So I think we need to move to the. I need to spell Hercules, correct? Wouldn't that be
Indeed.
nice if I could actually spell? You know,
Heracles?
I'm supposed to be a. Oh, where'd it go? Oh, no, I
Uh,
think we are. I think we can just slew to it. I don't think it's a problem. It's on the other side of the universe right now. Yes.
yeah, good.
Unfortunately,
Yes.
unfortunately.
Mhm. And just once again, yes, I know we have such alluring voices, Malcolm and I, but you're more than welcome to drop some questions in the chat here, and we'll do our best to answer them. And our moderators
Alluring
are.
voices.
Hey, that's true. That's true. You have to
I
when
would
you're.
have to, I would disagree, but I
Well, we have voices made for streaming.
okay. You know what? I won't argue with that. All right.
So our next target here is the Hercules star cluster. Once
Yes. Let us
we
see
load it
if I can get this going here. I hope so. We are in still mode. Oh no.
up, I think
Um, oh no,
I
did
think if
something
you
happen?
I think you're okay. If you go to I think it's capture, I think we can just do stacking. Oh, not that one.
We are in live stack
Um,
right now. We should be.
Oh, live stack, yeah. Camera's in still mode. Quick capture.
Oh,
There we go.
there we go.
You- Awesome.
A little brighter than it could be. So why don't I zoom out a little bit here?
Mm-hmm.
And why don't actually, you know what? Why don't we get a little bit, move down a little bit, because we're a bit higher than we need to be. Actually, you know what? Or should we leave it there? What do you think, Kyle?
Uh, let's move it a touchdown. Let's see what that does.
Okay, we can
Move
move
it
touchdown
just a touch.
just a touch. That's fine. Not 10 degrees. No,
No,
that would be bad. And
too much of a touch.
I believe it is actually up that we need to do for this one. It's a bit,
Mm-hmm.
everything is backwards when you do astronomy. Actually, while I'm doing this, we can actually discuss what I mean when I say everything is a bit
Ooh,
backwards. Um,
indeed.
in fact, it is
Uh,
so to the point. Why don't you, Kyle, discuss with them magnitudes and
magnitudes.
how we discuss how bright something is in the night sky.
Yes. So, okay. So it gets a little tricky when we're talking about brightness of things, right? Because stars and galaxies and nebula are at different distances, right? So we have to have some sort of standard of, what's our going to be our starting point for figuring out brightness, right? And so we've decided, astronomers have decided that that is labeled as the star Vega. It has a magnitude of 0, essentially. And what that'll mean is any star that is brighter than Vega will have a lower magnitude. So it'll dip into the negatives, right? So you could have like -1 or -3, right? The sun, for example, is -26 in terms of that, right? So it's so bright, of course, it outshines everything. Um, and the moon gets incredibly bright as well. But typically, stars that are really bright will float around, 1 or 2 magnitudes, and or magnitude, I should say. And it's essentially like a logarithmic scale, right? So it's I think the difference between magnitude 1 and magnitude 0 was 2.4 times, and then it's a multiple of that as you get higher and higher magnitudes. So that's essentially how we describe brightness, right? Now, what we were saying with how things are flipped in the telescope and in the camera, that's typically because there's a bunch of mirrors that are in telescopes, right? So what'll happen is the light will come in through the telescope. It'll hit the primary mirror at the back of the telescope. What'll happen is that light will then get focused to a point, and we have what's called a secondary mirror that again reflects that light back down the telescope. And then what will happen is we'll have some eyepieces that will then use some lenses and additional equipment which will flip the image around. Like the literally the light beams will flip each other, right? And that's how we get kind of a reverse image. So when you're taking out manual telescopes or any kind of other equipment outside, sometimes you'll have to make that adjustment. If you want to move your object left, you have to angle your telescope right, and up is down, and everything's kind of flipped, right? So it's kind of crazy here, but
Yes, yeah, we are getting there. We are getting there.
a
It
little
is
crazy.
starting to get a little bit more lined up. I have been recommended to actually
Hmm.
try doing this. So let's
Hmm.
see if I
Yeah, that's fine too.
can. Oh, look at that.
Get a little crazy, but yeah, getting some uh,
Yes.
um, behind the scenes scoop. So, which is
Yes,
pretty cool.
yes, yes. Unfortunately, things are no longer, or nothing is ever as easy as we make it look. So, um, kind of have to work with it, do our best. But so you've probably been
Good.
seeing, you've been noticing that every once in a while here we get a really lovely picture of this big star cluster. This is what's called a globular cluster. This particular one is the Great Herculean Cluster. Now, I'm not sure I can do it justice. So why don't you take it away a little bit here while
Ooh,
I try and
all right.
get this correct. Kyle, why don't you take it away and give a nice little explanation on what makes this one so special, or what makes
Absolutely.
globular clusters so
Globular
special in
clusters.
general. Yes,
Oh,
yes.
okay. So really, really cool. So globular clusters here, they're, well, I mean, the reason why they're called that is because they're a cluster of hundreds of thousands of stars, right? Typically, globular clusters will form around a place called the galactic halo, which is just an area around the center of a galaxy. And there are many, many different globular clusters that are in our galactic halo, with Hercules being one of them. Now, essentially, what happens is these star clusters do have a bit of a life cycle. So they will start out as, maybe a cluster of, two or three stars, or maybe four or five. And that kind of combined gravitational field will start to pull in more and more stars over the eons. Like these things take millions and billions of years to form. And eventually, an open cluster will form. Okay. Typically, those are younger stars that have been pulled together, about maybe 50 or 100, 200 stars in maybe an area of about 50 light years or so, right? But eventually, over billions of years, more and more stars will be attracted to this common center. And then you get this beautiful, again, great timing, Malcolm. Well done.
Thank you. Thank you. Took me long
Beautiful.
enough, but I got it.
Yeah, you got it. A beautiful cluster here that's made out of hundreds of thousands of stars. So the Hercules star cluster probably contains about 500, 600,000 stars. And located above our galactic plane, if you imagine the galaxy is like a dinner plate, it's located above it. And it's about 13,000 light years away. And so it's very, very far. And I don't know if you might be able to see it in the stream here, but there's a difference between, or sorry, there's some different colors in the stars. I see a couple blue stars, but mostly there's some yellow stars in there. So as these things age, they'll also attract older stars, right? Blue stars are very young, very energetic stars, and typically don't live for very long. So, star clusters that have lots of blue stars in them is usually an indicator that they're young star cluster. But again, we see lots of yellow ones and maybe some red stars in there as well, though they're too dim to see. Uh, but these yellow stars, just like our sun, um, can live for billions of years, right? Possibly even trillions, at least for these red dwarf stars. Right? So this is a very old cluster. Hercules is nearly as old as our own galaxy, which is about, I think, 11 billion years old, 11 or 12. Yeah.
Yeah, yeah, that's about right.
So, oh, she's getting there.
Yeah, they
Good
are
old Milky
quite
Way.
they are quite interesting, these globular clusters. And one of the
Mhm.
things that we need to, or we can kind of talk about here, is if you notice, one of the reasons how we know that they are this old is actually due to the color of a lot of these stars. Now, young
Mhm.
stars, as Kyle was kind of hinting at and getting to, are these blue ones. So these blue ones are the very young stars, and the reason they're blue, or sorry, rather, the reason we know they're young is actually because they're blue, because that blue indicates that they're super duper hot, which means their lifespan is super duper short. So they're not going to last very long. I mean, compared
Well,
to you and me, Kyle, they're gonna last. They're gonna outlast us by a long shot, but yeah, it's whatever. In the relative scheme of things, a few million to tens of millions of years is nothing compared to the 13 or 12 or 13 billion years old that you see some of these globular clusters being.
Mm-hmm. Mm-hmm.
Yeah.
So, and oh, okay. The thing is, these systems, they're also very dynamic places, right? With all of these stars, all packed in one place, all of those gravitational influences makes it quite a dynamic place. Stars will be moving around and going all sorts of which way. Okay, thought experiment again, like falling into a gas giant or falling into a black hole. If there was a planet that was orbiting one of these stars, there would be, like, if you were to look up into the sky, it would be essentially looking at city lights all of the time, and just so many bright stars all in one place. And it would be difficult to try and view like galaxies or objects that are outside of the star cluster, right? So, oh, if, if. So, good thought experiment, I think. But yeah, oh,
Yeah.
loving this. Loving this. Oh, it's been too long. Oh, and yes, visually seeing this through a telescope, because you can look at it through a telescope as well. It'll look like a dash of salt on a black background. People have described it. So
Yeah.
really, really cool. And like the name suggests, it is in the constellation of Hercules, hence the Hercules star cluster.
Yeah. So
Oh,
why don't we move? I guess we can move now to something a little bit
oh.
prettier. I'm just gonna put it out there. It is prettier in my opinion. You
No,
might
that's
you may
fair, fair.
disagree.
Yeah, yeah.
I don't know about you. I think it's prettier. I always find nebulas are like the prettiest things in the night sky, to be honest with you.
I
But
mean,
I
everything about space is cool. I have no favorites, but
that's I fair enough. Fair enough. I could respect that.
but I'm ready for some nebula, and I'm
Yes.
really good at this one.
Yeah. So this is going to be a very, very, very special nebula. Actually, this is not just any kind of nebula. So let me zoom in here. Make sure that we got a nice aim on it here. Okay, there
Should
we
be
go.
right on target.
Well, we hope so. We hope so. It's a little bit off right now. Joanna had suggested going into live view.
Hmm. I think you
I
have to
think I have to
unclick
clear.
live stack. Then.
Oh, yeah,
Yeah.
you know what? You're probably right. Okay, so let's do live
Boom.
stack. Oh, okay, there we go. And then let's see what happens here when we do this. Now, the only thing is that this is a
Mhm.
this
Maybe
is
zoom out a bit. Well,
this. Oh, yes, that's a good. No, I think it may be too dim. So we actually
oh, it can't be too.
we might have to live stack this one actually.
Oh yeah, 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 for sure.
Yeah, cuz this is I think this is a lot dimmer compared to, oh yes, there it is.
Oh,
You can start to see it right there. Okay.
and the ghost emerges from the
All right.
cosmos. Oh, that's so eerie.
So let me move down a little bit here so that we can actually, or I guess up. Oh, oh, oh. Okay, there we go. And we can slew up a bit just so we can actually see our nebula a bit more clearly. Now, you might be wondering why it is we are, like, why I'm having to do, and it's I think that's it
Oh,
there. Oh, either that or I lost it. You may be
I think you
wondering
just
why
go
it
back down.
is. Yeah, I will go back down. You may be wondering why it
Yeah.
is I am doing this weird thing where we are going and stacking images, and that actually has to do with something that we can kind of talk about compared to our eyes and kind of give you an idea of how bad our eyes are at looking at the night sky. When we look at really, really, really pretty pictures of things like this nebula down here, which is still unfortunately not very bright right now, which I can change quickly. Hold on. Oh, wow, it's very green, isn't it?
Mm-hmm.
Let's see. Oh,
A little bit too much.
I think so. Yeah, I think that did a little too much here. Um, oh no. Oh, I see what happened here. Let me reset that and then kind of see here if we can get this to look better. May want to increase the exposure a little bit here. So let me try doing that. But
Yep.
basically, the reason why we are doing this is because, yeah, our eyes are not great at seeing things in the night sky. So for something like our nebula here, we have to stack the images. So we have to actually combine the images on top of each other in order to um, well, combine the light, basically. So basically, we take a nice
Mhm.
image and then we start stacking it and stacking it and stacking it so we can combine hundreds and hundreds and maybe even thousands of pictures into one really nice picture. Now, unfortunately, I don't know why this is the case. I'll try loading a something here and hopefully we'll actually be able to get a better picture. But yeah, so
Yep.
what we want to do is we want to stack these images so that we can, in time, make a really nice looking picture. Now, onto the actual object. What are we looking at? So this lovely object down here, and let me see if I can zoom in a little bit on it, is known as the, sorry, is known as the, yes, I had to make sure I got that right, the Ring Nebula. So what is the Ring
Mhm.
Nebula? Kyle, what is the Ring Nebula?
Oh, okay. So it is a planetary nebula. So think of it as like a the remains of a long dead star. Okay. So a star actually like our own sun, that has gone through its life cycle and reaches the ending stages and will release its outer layers. Now, the thing is about, okay, I guess we have to talk about life cycle of of stars here, where pretty much what happens is, um, star will be born, go out its life, and throughout its lifetime, it's fusing hydrogen into helium, and helium into carbon, and there's like different stages. Okay, so what happens then is when a star reaches a certain stage, which depends on its mass, which that's a whole other thing, it will release its it will become a red giant phase, which is pretty close to the end at that point. And then what will happen is it'll release its outer layers. Okay. Now, all of those colors that are just working on getting the image a little better, but all of those colors, the reds on the outside and the blues in the middle, are due to different elements, with hydrogen and helium being the reds and oranges, with things like oxygen and things being the blues. And oh, you can just barely see it, but there's a white dot right in the middle of the ring nebula there. And that is the core of the star that was once there, called a white dwarf. And it's still incredibly hot from when the star was fusing, right? So it's white hot, but it's no longer fusing anymore. So what'll happen is over like actual quintillions of years will cool down, right? But the thing with those outer layers is they're going to continue to move away from that white dwarf, right? So eventually the ring nebula will get bigger and bigger. Now, why do we call it a planetary nebula to begin with? Well, I think that was all because of early astronomers looked at these objects and were going, that looks like a planet. I'm going to call it a planet. And turns out They were not a planet because planets, if actually this is really cool, if you picked up, will move across the sky over months and over years, right? Jupiter slowly moves across the sky. Mars and Saturn also do the same thing. Planetary nebulae do not. And so that was kind of a big clue that maybe this is something that's not in our solar system here and is actually part of the galaxy proper. And then we found out it has part of a star's life cycle. And holy geez, Malcolm, you're working your magic. Well done. Well done.
So I'm having a little bit of help, so I cannot take all of the credit. I'm doing my best here to make the picture look nice. So as it is
Mhm.
still pretty hard to see, but you may be able to see in the center there of that nice, lovely ring that there is a little white dwat. Dwat? English is a difficult language,
Aw.
apparently. So that is the little white dot that Kyle was talking about. That's that white dwarf. Now, Kyle, I don't believe I heard you talking about the
Oh,
actual formation of white dwarfs. So why don't I kind of take
we.
over there because this is
Yes,
something I pride myself in. I'm a little bit good at it. So yeah, so
absolutely.
basically what happens is there's basically three sort of possible or yeah, three possible things that can happen to a star when it dies. Now, I'm sure most of you have probably heard of something called a black hole. That's the most extreme case. It's also really rare and probably not like gonna happen very frequently. There is the middle case for like what we can I guess call middle mass stars, not really middle mass, but whatever. And that is what is known as a neutron star. And then of course there is the lowest case or the lame star. I don't really know what else to call it. It is the
Lame star?
lame stars because they're
Yeah.
boring. Yeah, it's the
Oh.
most common, and that is the white dwarf, and that's sort of what our star is going to do. So when our star dies, it's going to have this beautiful ring around it, this beautiful kind of nebula around it, just like this.
Hmm.
Yeah. First, it's going to grow really big and swallow the Earth up, but don't worry, that's in a few billion years. So yeah, we'll be okay. But yes, then it will emit this absolutely gorgeous nebula just like this, and it will
Hmm.
become a tiny little white dwarf, which is basically just a really hot rock and nothing else.
I mean, pretty much, yeah.
Yeah. Oh, I think my mouse got connected to the. Oh
Oopsies.
no! I
It's
think
okay.
I
You
think
just
my mouse got connected to the wrong thing. Oh wow, it is freaking out right now. Hold on. Let me get the
there we
black hole
go.
back down. There we go. Okay, sorry about that. Sorry about that. Technical issues. But yeah, so our star will do that, and unfortunately, we won't be able to see it. Now, that actually comes to another thing that a lot of the things we see in the night sky, they look really pretty from afar, but up close, if you were actually inside of it, they wouldn't actually really look nearly as pretty as what we see from the far.
Oh,
So,
really?
yeah, so like
Oh.
something like, and we don't, this is not an example of one, but something like a
Hmm.
stellar nebula, something
Mm-hmm.
like the Tarantula Nebula, or what's another
Orion,
very
I guess. Is
popular
that a?
Orion Nebula? Yeah, if you were
Yeah.
inside of them, you wouldn't see them in the same way that you would see this. So if you looked up inside the Orion Nebula, you wouldn't be like, wow, I'm completely surrounded by all these beautiful colors. Because the gas is actually really not that dense, right? So when we look at it from
Oh.
afar, it's because you have this huge cluster of gas that looks really condensed from afar, but if you go inside of it, it's actually really still quite spread apart.
Okay. So it's
Yeah,
almost like a going in a cloud in an
exactly.
airplane,
Yeah,
right? Okay.
you can see a cloud from afar and it looks, oh my gosh, look, this is a cloud. But when you're in the actual cloud itself, it doesn't really look like, I mean, unless it's a super duper thick and dense one, it doesn't look like, I mean, think about like fog, right? When you're in
Or fog,
fog,
yeah.
right, it doesn't look like it's this super dense thing necessarily that you're in compared to if you're seeing the fog from a distance, right?
Okay, that
Kind
makes
of the
sense.
same
That
thing.
makes
Yeah.
sense.
So why don't we move on to our
Cool.
next target here? I'm just
Oh
going
boy.
to make sure I get this one correct. Oh yes, yes. I hope you guys don't mind a little Dwayne the Rock Johnson because you're gonna need some salt and pepper for this next one. Get it? Get it? Cause we're doing the salt and pepper cluster.
Oh, I was thinking of like The Rock.
Yeah, no, I know, but you know the joke, like you know the joke, the can you tell what the rock's cooking? You know?
Oh,
Get it?
dang it.
Someone laugh,
Dang it,
please.
Malcolm. I'm a physicist, not a
Someone laugh,
comedian.
please.
Dang
All right, so let me just make
it, Jim. I'm
sure
a
that.
physicist.
Oh, it's okay. It's okay. I mean, it was a bad joke that was horribly executed. But let's zoom out
Something to
here
work
and go find our lovely clusters. So this is the Cassiopeia salt and pepper cluster is what this one is called.
on.
Oh yeah, it's a nice big
Excellent.
open cluster. So we
Okay.
previously talked about a globular cluster, and
Yes.
now we're going to look at an open cluster. So let me
Right.
just quickly not do that. Let me clear that. I think actually this one we might be able to get away with doing live view because it is an open cluster.
I guess we'll
Uh,
try it. Live stack might be a little bit better, but we'll see. We'll see.
yeah, I mean if the live view doesn't look good, then we can always just go back to live stack. It's not a huge deal. And I'm gonna say we go back to live stack.
Sure. Might have to adjust it as well in
I
just
will,
a minute.
yes, I will 100% do a little adjusting here. This is where I need to apparently work my magic. So let's slew down. I think it's down is the problem here. Again, unfortunately, when it comes to looking at things through a telescope and trying to reorient yourself to actually see things more clearly, it's never as simple as, yes, yes, this is correct now. It's a big thing of trying to finesse it into the right spot. It is still not in the right spot. So while waiting for me to figure it out,
Hmm.
how about why don't you explain to the lovely people what is an open cluster and why is it different from a globular cluster? And why isn't
Right.
there anything called a closed cluster? Why do we only have the open cluster?
Well, well, that's a good question. I mean, closed cluster would just mean like, oh, there's walls all over the place, right? Open cluster just means it's diffuse, right? So diffuse meaning it's not very tight or dense, right? So yeah, just like what we were saying earlier with open clusters. So now we're gonna see the other side of that. Maybe if you fiddle with the histograms, it might be able to work. Um,
Okay.
if you
Um,
can,
I've also been suggested to align frames, move the
yeah,
black
sure.
level down. Oh, yes, of
Yep,
course.
just like that. There we go. A
That
little
did
bit.
that. Yes, I will do. Hold on. Let me grab the blue a little bit so it can actually look a little more white.
Mhm.
Um, well, the stars can look a little more white, anyways. Yes.
Yeah, nice. Yes.
Yeah,
So
we're
open
starting to see
clusters,
lots of
right?
stars.
Hmm. Yes. So open clusters. So yeah, very, very, or it's not very diffuse, rather. So, or oh my god, not very dense. It's a Friday night. We'll get there. Um, and so So this is kind of the other half. So we just saw a globular cluster, very tight. And just remember that image, because now looking at this one, we see much more diffuseness, right? And even not a lot of color variance either. A lot of the stars are kind of more on the white, kind of bluer side, right? So it's really quite interesting. Now, what's interesting about the salt and pepper cluster is it's actually on the opposite side of the galactic center as seen from the Earth. So it's much, much farther away, right? Uh,
Yeah. No, it is. It
yeah,
is.
and
It's
so mhm,
super far away from us. Or rather, it's
yeah.
super far away from the galactic center, is what I should say.
Oh, yes, exactly.
Yes.
And uh,
Oh, no worries, no worries. It's actually so.
yeah,
Pardon
making
me. Let
sure.
me correct
Mhm.
my previous mistake of what I said. It
Oh,
is indeed something that is quite far away from the galactic center. However, it is actually not far away from us. In fact, it is
ah,
close enough to Earth that it potentially formed in our arm of the galaxy. So you may or may not know
whoa.
that our galaxy has a really
Hmm.
nice spiral shape. And
Hmm.
part of that spiral shape is it has galactic arms. So our arm, which you may remember the name of, I'm terrible with the Milky Way galaxy, ironically.
Oh, we're in the Orion arm.
Thank you. Okay, I thought so, but I'm not confident to myself. So yes, we are in the Orion arm, and
I guess more like
this.
the Orion Cygnus spur, I guess technically, but
Let me
anyway,
just
that's
scroll down.
the technical term.
Yes,
Anyway.
yes. Um, so yeah, we are in the Orion arm, and this cluster is actually close enough to us that it could have potentially formed in our arm of the galaxy. Now, one of the things about open clusters compared to globular clusters is that, as we mentioned previously, globular clusters are filled with all these really old stars, like few billions, tens of billions, or are at least over 10 billion years old. Those are really old stars. Open clusters are actually a lot different. In fact, most open clusters that we see are made up of super young stars. So a lot of these stars you're seeing aren't that red color that we saw previously. They're a much more white color. And yeah, and I can make this a little bit more, I can make it blue, but I don't want to force it. What we are seeing there is that the stars in this cluster are much younger than what we would see in something like a globular cluster. They're fresh stars, so it's a nice cluster of fresh stars.
Hmm.
But as Kyle was
Whoa.
saying, they're also a lot smaller in terms of their members. So when you look at a globular cluster, you see something in the tens of thousands or to the hundreds of thousands of stars in a really small area. So something like the Hercules cluster, it has something like 300 to 600,000 stars in it, but it's only like 100 or 200 light years across. Now, for something like an open cluster, you may have those same sort of sizes in terms of the distance, but instead of having tens to hundreds of thousands of members, you only have maybe tens or hundreds or thousands. So they're much smaller in size compared to a globular cluster, which I definitely think that we should call it a closed cluster from now on. Yeah, I think we should go to NASA and tell them that.
It's
Why do
official.
Yeah, why do we need to have all these convoluted names? Like you have open clusters, so
Hmm.
we could have closed clusters. I'm
One would
just
think,
saying.
right?
I'm just saying. See, this is why you should elect me the head of NASA. I'm just saying. It's a
You're
brilliant
on for
idea.
Artemis 8.
Yeah, no, you should elect me the new head of NASA. I definitely will not mess everything up. Promise. Do not do it, please.
Oh, but fair enough. Yeah, so brilliant clusters here, and sometimes we can see different shapes in them as well. Because they're going, this is a natural process for humans. Like we see faces and shapes and everything, right?
Yeah.
And is there one that looks like an owl?
There is. Yeah, there's even one that looks
Yeah.
like a rose or a screaming skull,
Oh,
which is a really
let's take a
goofy
look at them.
name for a cluster. But yeah. And
A little
actually
bit.
there is so if anyone's ever wondered what that word is, there is a actual word for it. That word is called pareidolia. So whenever you see a face or something
Oh,
like
right.
that in a otherwise unseemingly normal thing, yes, that is pareidolia.
Or like
Great.
creepy hands that are tapping the window when it's actually just a branch.
Okay, well now you're gonna make me like really scared now. I don't know what to I don't know what to do about that one. You
Hey,
got
I
me
mean,
scared, man.
Costco probably has Halloween stuff already, so I mean, might as well. No.
Why are you scaring me more? I don't want to be scared yet. We're not even close to Halloween yet. You gotta wait a little bit before we get into Halloween time territory, you know? I don't
Oh,
think that this is, let me see, let me center on the, oh yeah, there it is. Okay, so that is the target. That is the correct one. All right, good, good, good.
cool.
All right, let me reset our picture here. Clear. And we can get a new one going. So there is a lot of really weird naming conventions that we actually have while this is just loading in here. There's a lot of weird naming conventions we actually have in um, astrophysics and astronomy and everything like that. And one of the weird things is that there's never a consistent name given for a single target. So yeah, this particular cluster, which I will have to, this is the old one still, I need to re-clear it, which is okay. This particular cluster we're going to be looking at right now has many names. In fact, it has way too
Okay.
many, in my opinion. The most notable name, at least the one that it mostly comes up as, is the Caroline's Rose Cluster. I love that it's just a complete black screen right now, so they're not seeing anything. But there's also a few other names. So there is the Ghost Cluster, there is the Star Mist Cluster, there is the Herschel's Spiral Cluster, the Crab Cluster,
hmm
and the Screaming Skull Cluster.
Uh, whoa,
I don't know why they
whoa.
came up with so many names for one target, but yes, they did. You know, not much I could
It
do about
did.
it.
It
Yeah.
just happened.
Oh, yeah, it did just happen.
Wow.
Oh, it's quite a nice one though. It is a very nice target. So let's see if we can
Mhm.
slew into it properly here. Hopefully we can. Um,
Yeah.
let's
And
see.
yeah, the thing is, because we're dealing with really distant targets, we have to have some long exposure time. So it's unfortunately like it's a click, wait to gather the light, see if
Yep.
we're on it, click, move, that kind of thing. And again, I think we mentioned this briefly at the beginning as well, but it's we're trying to gather the light and stack those images on top of each other in order for us to see it.
And
Right.
unfortunately, I don't think I'm seeing it right now, which is unfortunate.
Oh, I
Yeah.
was hoping to see
So
a screaming skull.
I was too. I was kind of excited, but it may actually be the case that this one's too diffuse. I'm
Maybe.
not seeing
Not
anything.
seeing anything?
Let's see.
That's
Let's
fair.
try raising blue a bit here. And then, or we could wait a bit. We could wait a bit and see. Too low in the sky. You're in the northeast, which is
Yeah.
usually our thing. Okay, so this one may actually just be too low in the sky, so we may not be able to see it. Unfortunately, that's just another limitation of the fact that we live on the planet. So I think what we should do is we should start a GoFundMe, and we should move the entirety of SFU physics into space, into orbit. I think that's a good way to fund the next change to SFU physics. It may
Absolutely. That's
cost,
the next space station.
yeah, I think it may
Mhm.
cost several tens, if not hundreds of millions of dollars, but I think it's a great way of spending someone's money. I don't I don't know. Kyle, do you by any chance have lots of money? Because I do not.
No. But hey, maybe we can also invest in a space elevator too, so we can still have starry nights, but in
Oh,
space.
Ooh,
You
yeah,
know,
actually, you know what? That's not a bad
that
idea.
could be cool. That could
I think the owl cluster may also be too low because it is a little bit
be
lower
low.
in Cassiopeia. So, unfortunately, I do not think we'll be able to see that one either.
I'd say
Which
okay.
means, which means
Which
it
means
is time for, oh, whoop, wrong one. It is time for the stars of the show. And I just realized that that's not really a good joke in this case because this isn't actually a star, it's a something much bigger, but this is semantics or
are
something. I
we
don't know.
going extra galactic?
Oh, I think we are going extragalactic.
We
Yes, I do
are.
believe so. So let us slew
Okay.
and let us move. We are going to look at something even better than a small little cluster of stars. So we've looked at open clusters. We've looked at closed clusters or globular clusters, whatever the scientific
Check.
name is. Yeah, yeah, whatever. And we've talked about how open clusters have the tens to several thousands of stars. We have talked about the globular clusters, which have, tens to hundreds of thousands of stars. No big deal. Small rookie numbers. Let us now move to the big numbers.
Rookie numbers. I
Yes,
like it.
rookie numbers, rookie numbers. We are going to move into the big one now. We are going to move into galaxies. Yes, I did say it. We are moving into galaxies. Now,
Whoa.
I need to make sure that it actually, I don't know if it will come up for this one, because unfortunately, oh wow, that was easy. Wow, that was really
Look
easy. I thought
at
that was going to be more
that.
difficult.
No, that's cool.
All right, cool. Okay, so let's see if I can get this a little bit better centered. That is looking
Mhm.
spectacular. I do love me a good galaxy. Um, so let's move a little bit closer to here. Slew there. Um, and let's refresh this. Wow, even on 20 seconds, that is looking amazing. So I think, if I remember correctly, Kyle, this is one of your favorites. Yes? Oh, yeah, that is
Yes.
correct. All right. Well, then, in
Yes.
that case, I do believe it is only fair that I give this one to you.
Well, what can I say about one of my favorite galaxies here? So, this is the Whirlpool Galaxy, as
There it is.
aptly named for the beautiful, beautiful spiral that it has here. Okay, so upon seeing it, there's something else in the frame as well. It is another secondary galaxy. It's a more like a dwarf galaxy. That's and again, currently, this is like heavy quotes here. Currently, interacting with the Whirlpool galaxy. So, kind of like what you see on screen here is you have Whirlpool on the left and that companion galaxy or dwarf galaxy on the right. What's happening is that dwarf galaxy is actually a little bit farther, just a hair, just a touch farther than the Whirlpool. And it's actually coming in and slamming into the Whirlpool from behind. Okay? And what's going to happen is, due to all of those gravitational interactions and tidal forces, they're going to combine together and form an even bigger galaxy, right? It'll trigger star formation and even maybe some lots of maybe star clusters will eventually form billions of years down the line. But what is attracting the two are the central black holes in each of them. Okay. So the black hole at the center of Whirlpool is pulling on that dwarf galaxy toward itself, right? And this galaxy, I think, is about 30 million light years away. So you're seeing this beautiful, beautiful galaxy as it was 30 million years ago. And just a little bit about the image that you're seeing. There are some bright spiral arms, and even some like kind of darker smudges that are right in the arms as well, like directly in the arms. That is due, or those are just like nebula and dust lanes that are inside the galaxy itself. And you see a bunch of bright stars that are above the galaxy, and a couple to the bottom right, or sorry, bottom left there. Those are foreground galaxies, so that means that those are stars that are within our galaxy. That just happens to be in the way. So we can't actually see individual stars at this distance of the whirlpool, but it's quite quite fascinating, and it might be difficult to tell in the image here, but there should be some more bluer stars toward the edges with more
So you can see
like
like right in there. I
yeah.
don't know. I'm hoping you guys can see my mouse. Like right here where you can see the two galaxies combining here, there's like a little bit of a blue patch there you can see a little bit there.
Yeah, exactly. And with some, and towards the center of the galaxy, there it's more yellow, right? So that just kind of indicates that as galaxies are, forming and more like going about their day. I'm saying like it's so mediocre. Um, that
To them it is.
over yeah, over the eons, these older stars might start to migrate towards the center of these galaxies, right? Um, so you can almost tell the age of these things in essence, right? Another thing to point out, maybe Mike or Malcolm, you can help me out with this. So on the companion galaxy, just below it, there should be like a little dark spike going through it. And that's actually one of the arms from the whirlpool. That's just in front of the.
I think that's that yeah, it's
Yeah.
not really I think I can see what you're meaning here. Like this you can see this
Hmm.
like kind of triangular shape kind of coming out
Yeah.
and poking in there. Yeah, I can see what you mean there.
Yeah. Yeah. Exactly. So that kind of indicates, or indicates that companion galaxy is behind whirlpool. There.
Yeah. Yeah.
Yeah. And even a little picture you can find online is there is telescopes actually took a picture of the central black hole of whirlpool, and it almost looks like an X, which actually it does pretty much look like an X there. So that's a little bit of homework for you guys, is to maybe go and look at some images of the whirlpool galaxy of its central black hole, and you'll see this X there. That's not the black hole itself. It's just some dust lanes that are obscuring the dark monster within. But yeah. Oh my gosh, I
Yes,
love this. I
unfortunately
could
we cannot actually see a black hole with our own eyes.
no.
Something about it, sucking, I say with
Mhm.
quotations, all the light in. Don't take my word for that. They don't actually suck in light. That's a really horrible way to describe it. But yes, you can't actually
Mm.
see them correctly because all the light is bent into them, and light cannot
Yes.
escape it, unfortunately. Yeah.
Yeah, yeah. That's fair. But oh my gosh, I could stare at this for so long.
Well,
So
I
long.
think why don't we continue on here as much as I know you would love to keep seeing this. We do have more things to look at, so why don't we continue on here a little bit and move into
Okay.
our hat of the day. I'm sorry, I
Our
hat.
hat.
Our hat. Yes, our hat of the day. I'm a bit of a person when it comes to hats. I do like my hats. So we are going to go look at a hat.
We're gonna look at a hat. Oh,
We're gonna look at
I
a
hope
hat.
it's cheap. I hope it's a cheap hat. I don't know.
You never know. Hats are
Well, yeah.
hats. I mean everything's expensive now, but like good hats. You can probably find good hats not too expensive. I mean, this one's probably not that expensive. It's just it's
Really
it's
big
just a little bit far away from us. Yeah,
and far away.
it's kind
Yes.
of far away, and it wouldn't fit on your head.
I mean, fair. Yeah, that's fair.
Yeah, yeah. Unfortunately, this particular hat would not fit at all. I mean, you could probably try and make it fit, but you would have to have a really big head. All right,
That's true.
let's
That's true.
see if this is now aimed correctly. Let us clear our image because I don't want to stack two galaxies on top of each other, although that would look really funny. Ugh! It's green!
We're coming out of warp drive.
Apparently, yeah, no kidding. Holy
Hmm.
moly. Okay, there we go. Now we're starting to make it. Now we're starting to make some sense of it. Okay. I like making sense of things. I do like it when things, when everything comes together. That's when we're all happy at the most.
Oh, this
Confluence,
looks
point together.
so neat.
Yes, yes. We have ourselves, and let me just make sure I am in the correct frame. So the dark is on the bottom here, and in our
Hmm.
picture, it's on the top, which means I need to go a little bit closer to the bottom. I need to go a little bit closer to the. I'm not going to be allowed to, am I?
Yeah, it looks pretty good. I think.
Uh, well, okay, all right. Let's see. Can I move? No, I can't move that down that way. So that's okay. That's okay. Let's actually get to our picture here, so we can actually start looking at a galaxy here. Okay.
Hmm.
So why does this one look so much different, Kyle? Why does this galaxy look so much different from the last galaxy? The last one, it looked amazing. It looked like this nice disk, but this one just looks like a line.
Right.
That doesn't make any
Okay.
sense. Why
This
does
is
it look like a line?
a little bit interesting. So, essentially, oh, excuse me. Essentially, imagine galaxies, and I should say spiral galaxies because there's different types of galaxies. There is something called irregular galaxies, which is just a jumbled mess of stars and dust and whatever. Then you have beautiful spirals, which are great to look at, great to take pictures of.
Like
Astronomers
this
love
one
them,
right here.
like this one. And there's something called elliptical galaxies, which are essentially just big spheres of stars, matter, and dust that are millions of light years across. Or sorry, hundreds of thousands of light years across. So this, if you imagine spiral galaxies as plates, literally a dinner plate. I mentioned this a little bit earlier with a ball rolling around on it. But if you imagine spiral galaxies as dinner plates, they can be in whichever orientation, whatever, in the universe. The Whirlpool galaxy was nice and oriented beautifully, where we can see its lovely shape. We call that face on. So we see the face of the galaxy. The Sombrero galaxy that we're looking at right now is edge on. So if you were to turn that dinner plate so you're looking at its edge, you're just seeing it along the plane, right? So that dark line that you're seeing there is actually the edge of that dinner plate. And that glowing center is more in the toward the center of that plate. So I think this is a really good view of it. Maybe some people might say, "Oh, maybe we didn't get too lucky with seeing it nice and beautiful and edge on." But seeing beautiful pictures of the Sombrero Galaxy that Hubble is taken and things, it I think this is a good view. It's really really good. They're really also really far away. It's over 30 million light years away. Just a correction. Whirlpool was about 25 light years away.
Just 25
Sombrero
light
is
years away?
or, oh my gosh, 25 million. Oh my gosh,
Sorry, I had
25
to. I
million.
had to. I saw the
Oh
opportunity.
yeah,
I had to take it.
only 25.
Only
Yeah, it's only
25.
25.
It's not so bad.
Mm,
It's like
not so
a
bad.
a cosmic grocery shop away.
Oh yeah, absolutely. Um and so this one's about 31 million light years away.
So this is what it looked like
And
31 million years ago. It's not what it looks like right now.
no, yes, light still takes time to get to us,
Yeah.
right? Right. And there's hundreds of billions of stars within, just like every galaxy. It has a supermassive black hole that is possibly a billion solar masses. Um, ours is about 4 or 5 million solar masses, our supermassive black hole.
Yeah,
And
ours
it's
is kind of
about
small, isn't it?
ours is a little bit small. Yeah, not very big. Um, and its sombrero is about 30% the size of our Milky Way. So
Which is kind
Milky
of an
Way,
interesting difference there, isn't it? That we have
yeah,
a much smaller supermassive black hole at the center of our galaxy, but we are a much larger galaxy in comparison.
it's almost like it's denser. I think, right? Kind of feels that way, right?
Well, it's interesting you
Um,
bring that up because it does actually have a high population of globular clusters in it, which of course
mm.
are those very dense
Oh,
star areas.
okay,
So you might
that's
be
pretty
right. Yeah,
interesting.
you might be onto something there.
Okay, there you go. So, just to give you an idea, I believe the last estimate of our Milky Way galaxy is about 100,000 light years across from end to
Yes.
end. Pretty big. So, yeah, Sombrero would be much, much smaller than that, right? So, I think what's that, about 30,000 light years across?
Something like that. Depends on if they're talking, it depends on if the metric for 30% the size is 30% the diameter or 30% the area, which, we're really bad about actually doing this. So
Yeah. Thing is, point is, it's smaller.
it is small. It's much smaller compared to ours, yes.
Hmm. Yeah, fair
But
enough.
but
Oh,
the most important thing about this galaxy is it
mhm.
does in fact look like a sombrero.
Yes, it looked like a hat.
Yeah.
A lovely
I mean,
sombrero, especially with
if I
this.
could if I could wear a hat like that, I would wear a hat like that. That's a cool hat in my opinion. Yeah. I
Hmm.
mean, my head would
Right.
probably be crushed by the weight, and then I would also have to deal with the horrible force of the black hole at the center, but semantics.
Semantics.
It's always
Semantics.
semantics. Semantics will get you. You never know. Semantics will
Hmm.
always get you. You got to be careful about semantics,
That's true.
Yeah.
That is
Yeah, you
true.
got to be careful. You got to be careful, yeah.
Hmm.
So,
Ooh.
there is a little bit interesting something about this galaxy. When we're looking at this
Oh.
galaxy, we're seeing that nice dark line there. Why are we seeing that dark line? Why is it that this galaxy looks like this really nice bright bulge and then there's just this sudden black line that goes straight through the top of it? Well, that's actually due to an area of star formation. Now,
Oh.
in our
Okay.
galaxy, we do
Hmm.
have areas of star formation. You may know them as nebulas. Now, not all nebulas are born the same, and not all nebulas give rise and birth to stars. However,
Okay.
certain nebulas do. So the planetary nebula we looked at earlier doesn't. So unfortunately, we can't trust that one to make a nice big amount of stars afterwards. But something like the previously aforementioned Tarantula Nebula, or the one that is actually visible in the northern hemisphere, something like the um, I lost it, Orion Nebula, the Great Orion Nebula, that is an area of extreme star formation. Now, I saw someone earlier in the chat mention a star called R136A1, which, yes, it is a horrible name. I agree completely. But R136A1 is actually a really cool star. And the reason it is such a really cool star is because it is one of the most massive stars in the entire known universe. Now, that might sound special, but you got to
Whoa.
remember our known universe for stars, like individual stars, is our galaxy and nothing else. But you can try to imagine that This star, R136A1, is estimated to have a mass over 200 times our sun. So imagine our sun 200 times in one star. And that star and many like it are being formed in this Tarantula Nebula and in many other nebulas throughout our galaxy. And these are these
Mm.
areas of big star formation. However, what makes this so unique is that we see this huge line that actually cuts through Sombrero Nebula or Sombrero Galaxy, where you're seeing this star formation, which isn't necessarily what we would see if we saw our galaxy from the side.
Wow.
Yeah. Yeah. So, if you ever think about why sombreros are really cool, just remember sombreros are cool because they form stars. No, that doesn't sound right.
What?
It's okay, whatever. You know, it is what
What?
it is. Close enough.
Close enough.
Yes. Sombreros are cool because they make stars. That's why. So
Yes,
if you
yes,
put a
yes.
sombrero on, you'll be a star. There we go.
Now that is should be a bumper sticker.
Oh yeah, that should be I will happily have that bunker sticker. All right. So moving on to our final target of the evening.
What
I
already?
know we're already moving on to our final target. Well,
Oh my!
unfortunately we did have to we did have to skip a couple because they were
They were too dim. Yeah.
well, it wasn't that they were too dim, it's that they were too low.
Mm.
Yeah.
Oh yes,
So we
yes. Low.
normally we would be able to look at them, but unfortunately this time they were just too low.
Too
However,
low. Wah, wah.
that's okay because I'm going to be honest, galaxies are still way cooler. Its galaxies are better.
I mean galaxies. Yeah. It's like a whole, a whole galaxy of possibilities when you look at these,
Oh
right?
my god. Oh.
I had to. I had to.
I know you did, but it's so bad. Oh no, not the puns. They're already coming out.
I mean,
Oh
hey,
man.
we're
Oh,
observing cool
I'm seeing
things
a
on a
galaxy.
Friday night. Oh,
I'm seeing a galaxy. Oh, look at that. We are seeing a galaxy. We gotta wait for it to stack a little bit, but
yep.
that's okay. So we should actually give a name to this. We shouldn't just call it the galaxy. I mean, we could call it the galaxy,
The
but better names to call it. So this
the
galaxy, which is slowly coming into view here, is called M106. Yes, that's it. That's its only name. It does not have a cool name because apparently they were too busy giving the Carolina Rose Screaming Skull Cluster every single name, and they just forgot that this one needed a name still, unfortunately. But I guess you just can't trust astronomers, man. They just
making
yeah,
up names.
yeah, you can't trust astronomers to actually give things proper names. I mean, I think that we
Eh,
could come up with way better names than, R136A1. Like, what a lame name. You should call it the super awesome megastar that destroys everything in its path, or like Gargantuars. I think we actually already came up with something like that, but yeah, whatever.
well,
All I'm saying is
Gargantua was
we need a
the.
better naming scheme in astronomy. So
That's true.
you should, if you are watching, you should 100% email NASA. Don't do this. You should email NASA and tell them, hey, we need better names for things in the night sky. I'm giving really bad advice.
Oh yeah, they'll get right on that for sure.
Oh yeah, they will. That is the most important thing. So,
That's true.
what are we looking at? We are looking at M106. It's a similar galaxy to our own, a spiral galaxy, except that it's not anything like our galaxy whatsoever. There is something very unique about this galaxy. Very unique about this galaxy. And that is called what is known as a mega maser. I am not making that word up. Somebody else. Oh, I'm sorry. I've been informed that I came up with the wrong name. Do not email NASA. Email the International Astronomical Union, and you can blame Dr. Joanna Wu for telling me that. So now I'm telling you guys the right way to go. See, that's even worse now. It's digging a hole here. Anyways, so M106 is a similar galaxy to our own, except that yes, it has something called a mega maser. But what the heck is a mega maser?
Yes.
We all,
Uh,
you may know what a laser is. I'm sure if you have
mhm.
a cat, you definitely know what a laser is because cats love laser pointers. Absolutely love laser pointers. Lasers are focused beams of light. A
Okay.
mega maser, or just a maser, is also a focused beam of light. However, lasers are with visible light. A maser is not with visible light. A maser uses microwaves, similar to that appliance you guys have in your kitchen. So
Mhm.
there you go. You guys are the source of masers. Congrats. And in fact, actually, this is using something similar to our own, is to what you have in your kitchen is using water vapor mega masers. So it's masers, I believe it is from water vapor within the galaxy.
Yes.
Now, what does this have to do with anything? Well, there's a couple of important parts of this galaxy besides this. One of them is that it has an active galactic nuclei, which we will get into in a little bit here. But let's focus more on this mega maser and why this mega maser is so important. So, first off, the Milky Way galaxy does have masers in it. However, mega masers completely dwarf anything the Milky Way has. In fact, the mega masers that you might see, well, you wouldn't see, but NASA or a telescope might see coming from a galaxy are around 100 million times brighter than any masers in the Milky Way. So imagine taking our gal or our or actually even better, taking a flashlight and then shining it at your face. It's going to be bright. Now imagine taking the sun and shining it at your face directly there. Of course, I'm exaggerating just a little bit, But you can imagine that that is a huge difference in brightness. Extremely different in brightness. Like that is way brighter than anything we have in the Milky Way. And they've actually played a pivotal role in something important to cosmology and astrophysics completely. This particular galaxy, M106, the mega maser in this galaxy, was actually used to help correct our estimate for the universe's age, which is crazy. That something as
Whoa.
simple
Yeah.
as a laser made of microwaves could actually tell us, yeah, your age of the universe, wrong. Try this one instead. And that's really cool.
And
And it's kind of brings a sort of idea that there are so many different things in the universe that can tell us completely seemingly unrelated things that you would expect like, whoa, how did we get this from that?
mhm.
It's pretty crazy. Wow,
Wow.
I think I've been kind of talking over you here. Sorry about that.
No, no, you're good. I'm just amazed at this as well. Like every time I look at these galaxies, right, just seeing the possibilities in them, and especially I didn't know about that actually until discussing it with you. It's quite amazing that these techniques allow us to navigate the cosmos and figure out things like how old our universe is, right? Because I think
Hmm.
the previous estimate was 13.7, and then this mega maser here was put it to 13.8. I think like
I think so.
redid it.
Yeah, I think that's
Yeah.
yeah, yeah.
hmm 13.8 million or geez, million billion years old.
That's pretty old. That's pretty old. Yeah.
Wow, that is pretty old. That is pretty old. Okay, and then the one thing about the names, I thought I'd just talk about this for a sec because at least like the M106 or M13, that's the Hercules cluster, is M13. That was all due to an astronomer, and his name was Charles Messier, who came up with this catalog to determine all of the objects that he was observing. He was actually trying to find comets, actually, way back when, and but of course, the technology at the time, he what he thought were comets, they turned out to be like the Ring Nebula, the Whirlpool Galaxy, Hercules Cluster, and M106 here. And so, as technology progressed, astronomers realized that these objects weren't, in fact, comets. They were actually things that were outside the galaxy or within the galaxy, right? But the catalog stuck, which is why we say M number, is because M stands for Messier. But I mean, that star's catalog number was definitely not a good name.
I think we should definitely change it to M for Malcolm. Just saying, just saying, just putting it out there. That's another thing, you guys, we should definitely vote on. We should come up with a
Mm-hmm.
vote. Yes, let's change it to M for Malcolm. I'm just putting it out
M for
there.
Malcolm.
It's got a nice ring to it. It's got a nice ring to it. So I've
I
seen a
think
little bit
so.
of discourse in the chat regarding AGNs, or active galactic nuclei, and of course we were talking about this big galaxy and how this big galaxy has indeed an active galactic nuclei in it. But what even is an active galactic nuclei? What does that even mean?
Uh, Active galactic nuclei. Okay, so it's talking about nuclei, the center of the galaxy, right?
That's
And
this
pretty
nice
much
big
in
bright
almost
thing in the center, by the way.
that big bright thing, yes. In the center of almost every galaxy is a supermassive black hole, right? So that is the galactic nuclei, okay? Is the black hole. Now it's active in the sense that it is actually eating stellar mass that's surrounding it, right? And it's collecting all of this mass and it's getting sucked into the black hole. And what happens is some of that material gets shoots off out of the poles of the galaxy, north and south, above and below the galactic plane, and it shoots it off. And so essentially, active galactic nuclei just means it is actively feeding,
It is, yeah.
essentially.
It is
Yeah.
actively feeding. It's growing. It
Hmm.
is there is so there's the what is known as, I think, as the accretion disk. Yes, the accretion disk
Yes.
around the black hole. Basically, there is matter from the accretion disk that is going into the black hole. It is growing. The black hole itself is growing. It's increasing in size. And as this matter enters the black hole, it actually emits a lot of energy, which is what Kyle was talking about there,
Mhm.
where you're seeing this huge amount of energy. That's what we're seeing, is we're seeing the energy as matter gets consumed by the black hole. Now, this is really
Mhm.
bright, actually. These, not in the visible spectrum, of course, because nothing cool ever happens in the visible spectrum of light for some reason. Don't know why. But, well, I mean, life happens in the visible. It doesn't matter. Anyways,
Mhm.
basically, it's like this mass around the black hole is getting pulled in by the gravity, is one way to look at it. And so the black hole
Mhm.
is growing. And that is why we call it that active galactic nuclei. It's actively increasing in its size.
Mhm.
The Milky Way, once again, holds its beautiful reputation of being completely boring and does not have an active galactic nuclei.
Aw.
Yes, unfortunately, our galaxy, despite being extremely unique in that it hosts life, doesn't have anything else cool about it. Yeah.
Well, it is home.
We chose a really boring galaxy, I think.
I mean, I pre- I prefer peaceful. How about that? For the most part.
That's a good way to put it. I like that
Uh,
too. Yes, we have a peaceful galaxy.
exactly.
Yes,
And
there's no Star
I,
Wars going on here.
yeah. Okay. And I think that'll bring us back home here to a close. We're just kind of seeing, we're just nearing the end of our time here. But again, seeing these beautiful planets, clusters, nebula, galaxies, I always love the perspective of all of this as well. I love the Milky Way. I love how peaceful it is and how we can observe all of these beautiful things from our lowly oasis in the solar system.
Yeah.
I think. hmm It's
No, it's
quite
it's a
nice.
wonderful way to wrap it up.
Yes. Do you have any closing remarks, Malcolm?
I don't think I can put it any way better than that, except that I do still believe that
Oh,
we should put SFU physics into space. I'm just saying, and
just saying.
we should start, trying to fix the naming convention
Mm.
of astrophysics and astronomy. Yeah, we really need to do something about that, man. They've made a mistake there. I'm just saying, if you put me in charge, I'm just saying it would be better. It would be better.
We got a list. We got a list we need to do
Yeah,
for
yeah, we
next.
got a list. We got a list. So there's lots of things. There's tons of things that need to be, or tons of things. Haha. See, get it? Because someone mentioned Ton 618. Get it? Haha.
Mhm.
Anyways, so there's tons of things that need to be renamed. I think, anyways. Like everything just come up with cooler names. Like
Awesome.
well, I can't think of
Awesome.
anything right now, but I'll get back to you on that.
We'll get back there. Yeah, absolutely. Oh, so I think that finishes it up here at the Trottier Observatory. Thank you once again to Matthew and Rohit in the chat for helping out with questions and comments. Um, Malcolm, what an amazing job today. Well done. And thank you so much for Joanna for support on the tech side as well.
Yeah, well, thank you as well to I want to also give a brief thank you to Kieran and Joanna both for
Yes.
also being helpful. And you may have seen that at some points there was some stuff going on with the picture getting much nicer in the background. Uh, that wasn't always necessarily me or Kyle. Sometimes it was Kieran working in the background. I think maybe it was also maybe Joanna. I don't know if she's actually currently
hmm
on right now, but yes, big
Yeah.
thank you to both of them for always being a huge help. And yes, and thank you all for joining us as well.
Thank you so much, everybody. Have a good evening.